All right, here we go. Motion, forces, and energy. We're still in chapter 1. We're doing section 2, acceleration. Okay, so for acceleration, we are going to look at, we're going to define acceleration, and we're going to predict what effect the acceleration will have on motion. Okay, whenever the motion of an object changes, it is accelerating. Remember, what does it take to change velocity? 3 things can change velocity. And we're going to learn what acceleration is. All right, here we go. Whoops. Acceleration and motion. When you watch the first few seconds of a liftoff, a rocket barely seems to move. With each passing second, however, you can see it move faster until it reaches an enormous speed. How could you describe the change in the rocket's motion? When the object changes its motion, it is accelerating. Acceleration is the change in velocity divided by the time it takes for the change to occur. Like velocity, acceleration has a direction. If an object speeds up, the acceleration is in the direction that the object is moving. If an object slows down, the acceleration is opposite the direction the object is moving. What if the direction of the acceleration is at an angle to the direction of motion? Then the direction of motion will turn toward the direction of the acceleration. Okay, this is a very good introduction to what we're going to be talking about. There are 3 key points in here, but I want you to think, what is the first thing you're going to write down after you get your outline started? So we need to acknowledge that we are in a new section. So we have this big red heading, and then we have this blue heading. So our red headings are Roman numerals. This is section 2. So you'll write Roman numeral 2, acceleration. And then under that, the part of the outline, the next part of the outline, will be a capital letter A, because this is the first blue heading. And then we can do our details. So let's look at what we're going to write. Okay, you're writing Roman numeral 2, acceleration, capital letter A, acceleration and motion, that's the heading. And the facts in here are that it's the change in velocity divided by the time. If it's positive, the object is speeding up, and if it's negative, the object is slowing down. Now, it wasn't worded that way in the book, but I don't think we could quite understand what was written in the book. So I kind of cheated for you a little bit. All right, pause it and return when you're done. All right, speeding up. You get on a bicycle and you begin to pedal. The bike moves slowly at first and then accelerates because its speed increases. When an object that is already in motion speeds up, it is also accelerating. Imagine that you are biking along a level path and you start pedaling harder. Your speed increases. When the speed of an object increases, it is accelerating. Did we already just say that? Yeah, we did. Okay, suppose a toy car is speeding up, as shown in figure 7. Each second, the car moves at a greater speed and travels a greater distance than it did in the previous second. When the car stops accelerating, it will move in a straight line at the speed it had when the acceleration stopped. Okay, this startled me a minute, Josh, because it said when the car stops accelerating. I was predicting that we're talking about the car stopping, but no. When the car stops accelerating, it is now moving at a constant speed. Let's look at figure 7, okay, Christopher? So it would back up a little bit. All right, notice the cars here. The cars are getting farther apart because the object in between each interval of time is accelerating. Okay? All right. Let's see, what are we going to write? We have a red heading. This is a number 1. Okay? And you are going to luck out because watch what you get to do. All right? So you are writing number 1, speeding up. We're not going to really write any facts here because it's just too much information. So this is a little different, but you can go ahead and write these down if you want. Speeding up, slowing down, changing direction. Okay, those are the three ways in which you have acceleration. What does that remind you of, Max? Okay, three ways acceleration changes, and the three ways that, what are the three ways that velocity can change? Remember that? All right, slowing down. Now suppose you are biking at a speed of 4 meters per second and you apply the brakes. This causes you to slow down. It might sound odd, but because your speed is changing, you are accelerating. Acceleration occurs when an object slows down as well as when it speeds up. The car in figure 8 is slowing down. During each time interval, the car travels a smaller distance, so its speed is decreasing. In both of these examples, speed is changing, so acceleration is occurring. Because speed is decreasing in the second. What movie is that from? All right. Let's see. Anytime an object slows down, its acceleration is in the direction opposite to the direction of its motion. This is information you will use when you get into physics class. All right, so now we have our car. You see 0 seconds, it's here. Okay, at 1 second, it's at 30 centimeters. And then same time interval, but it doesn't travel as far because it is slowing down. What do we call that? It starts with a D. It's the opposite of acceleration. Caleb, you be sure to tell us when you get to school tomorrow. Alrighty. So that's our red heading. Red heading, slowing down. Got it, Bo? Perfect. Changing direction. Okay, remember the three ways that velocity can change is if the speed changes, the direction changes, or they both change. So velocity has direction to it. Acceleration also has direction. So changing direction is another way that we can change our acceleration. Motion is not always along a straight line. If the acceleration is at an angle to the direction of motion, the object will turn. At the same time, it might speed up, slow down, or not change speed at all. Again, imagine yourself riding a bicycle. When you lean to one side and turn the handlebars, the bike turns. Because the direction of the bike's motion has changed, the bike has accelerated. The acceleration is in the direction that the bicycle turned. Figure 9 shows another example of an object that is accelerating. The ball starts moving upward, but its direction of motion changes as its path turns downward. Here the acceleration is downward. The longer the ball accelerates, the more its path turns toward the direction of acceleration. Okay, so ask yourself, what are the three ways to accelerate? Speeding up, slowing down, or changing direction. All right. So, all right, we did all that reading, but we only had to write these three things down. And I have to pause it. I'll be back. Okay, I think this is where we left off. We have the heading calculating acceleration. If an object is moving in a straight line, its acceleration can be calculated using this equation. Now, this looks confusing, but it doesn't have to be. Okay, the acceleration equation. Acceleration is meters per second squared. You take the final speed minus the initial speed divided by the time. So this is what we're going to write down. I'd like you to actually go ahead and write this down now. We'll come back to it. All right, in this equation, time is the length of time over which the motion changes. In SI units, which is the industry standard, international standard, acceleration have units of meters per second squared. All right, so let's go back here see where we're going to move forward to. All right, so I want you to write B, calculating acceleration. Don't write this, okay? I want you to write, okay, so you write capital B, calculating acceleration, and write this equation right here. Okay, write it exactly like you see it. It's going to take 2 lines on your notebook, but that's okay, because this looks like what we're going to use. Okay, see how this looks much more clumsy than this. Okay, this is much easier to understand than, whoops! Okay, it's the end of the day, and Lucas is trying to get in here, and Cameron and the radio club, so, or the games club. All right, so I got to get going. All right, here we go. All right, positive and negative acceleration. An object is accelerating when it speeds up. You know what? We're just going to skip this. Blah, 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 blah. All right, because the game club needs to get in here. All right, so point of the matter is, you're writing number 1, positive and negative acceleration. A, the fact is positive means you're speeding up, and if the acceleration is negative, you are slowing down. Now graphing. We spent a good little bit of time on graphing. Okay, blah, 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 blah. We're going to look at this picture here. We're going to say that this means that we are accelerating. Our speed is increasing. What's happening here at B? What do you think there, Abby? What's happening at B? Is our speed changing? And then at this point, what is our speed doing? Have you guys ever heard the saying, a picture's worth 1,000 words, Ethan? Have you heard that? Okay, a picture is worth 1,000 words. All right, so we are going to write down the facts that on a graph, if we have a slope that is positive, your acceleration, you are speeding up. If you have no slope, your acceleration is 0. You are not, you're at a constant speed. And if your slope is negative, you are slowing down. Oh, hello. What did I just say? Is this what I said, Parker? Graphing, accelerated motion. Positive slope, you're speeding up. Kyle, a no slope is constant speed. A negative slope, Colin, is slowing down. Okay? There you go, Landon. Zoom, zoom. Goodbye.